thank you, GE Vernova. Now I have to adapt team for hosting this event. So my name is Massimiliano, and I work at A2A, and I will give you a short presentation of our company in a while. I joined this company 5 years ago, and ever since I've been part of an in-house monitoring center that works on our thermal power plants, which pretty much means combined cycles. So let me start this by giving you some context about our company, which was formally founded in 2008 when two very old, much older public companies merged to create this utility that is one of Italy's largest utilities, and you'll see we'll have several business areas that we operate in. A further big change started in 2021 when a new management took office and they launched a multi-year, multi-billion business plan revolving around sustainability, and this plan has two main pillars: energy transition and circular economy. Well, here you can have a look at our main business areas and a few key figures about our company. We have power generation, where we have thermal power plants, again, mostly combined cycles. We also have hydro, and we're growing fast with solar and wind. Then the environment, there's about waste collection, waste management, and waste-to-energy power plants. Sales of natural gas and electricity, district heating, distribution networks, water cycles, public lighting, and some new things such as e-vehicle charging stations. We have a workforce of over 13,000 people. Last year we had revenues in the neighborhood of 14 billion euros with a bit close to 2 billion euros. As I said, I've been part of a monitoring center that was set up over 5 years ago. We do monitor our thermal fleet and specifically combined cycles. We have the cloud version of what was SmartSignal as our main tool to do so. We have 6 different sites. Most of them are in the north of the country. We also have one in central Italy. They combine for some 9 or 10 gas turbines, and they have equipment from different manufacturers. Regardless of this, we were able and have been able to develop all the models, all the monitoring tools that we need in this APM reliability. So, what was our journey like? The real experience, the first acquaintance with SmartSignal dates back to over 15 years ago at a power company that was named Eddy Power and which was later acquired by A2A. With APM itself, the story starts in 2016 or 2017 when, after a couple of rough years, A2A started a cooperation with GE that was aimed at implementing a very large revamping package for a couple of combined cycle sites. The adoption of the cloud-based APM reliability was a part of this larger revamping package that was aimed at increasing reliability and flexibility for those units. Starting in 2018 until 2020, we completed the rollout of APM reliability deployments to all our fleet. Sometime between that, in 2019, the monitoring center was established at A2A Power. We cooperated with Paris-based GIMS for some 1 year and gradually took over from them. We started with monitoring, with alert processing, then we evolved with model maintenance, first low level like retraining, all the way up to adjusting the blueprints to make sure that we're closer to our real pieces of equipment. Over the past couple of years, we have also developed, not in APM but outside APM, I will discuss that later, how we need to combine the two things. We have developed new analytics to better match the current way our equipment is operated. That has been changing lately. Challenges and achievements throughout the journey. Well, there was a full keynote about the first one. So the main driving force, and I think everybody in this room agrees upon that, is people's trust. When you start anything like this, probably you'll find skepticism, and this is what we found. Sometimes reluctance as well. But after you get your first key wins, things start to change, and that's the fuel, again, to use the terminology that we learned yesterday. So this was the biggest challenge, but back to implementation stage, we also had to deal with pure documentation. Sometimes we didn't have enough historical data, and that somehow slowed the process a bit. Fast forward to nowadays, we're grappling with model maintenance. It has taken us too much time. We're close to a point where we cannot cope with that anymore. And that means that we are not able to adjust and to update our models as frequently as needed. We started a discussion with GE people to understand if there's a way we can improve our workflow. And at the same time, we started working with our data scientists to try develop something that can automate, to some extent at least, data cleansing. The biggest challenge ahead for us is adapting to a changing market. We have been using APM reliability and SmartSignal in the first place for steady state monitoring. That doesn't mean that we're only looking at our machines when they are working base load. This means that we wait, just to make it simple, we wait until the gas turbine is what we call environmentally compliant, and from that point on, we start our monitoring with our existing SmartSignal or APM reliability tools. This means that we ignore the ramp up, all the startup and coast down situations. It's hard to say for sure where the market is going because the past few years have been quite fuzzy, I would say. But there is a feeling that such units will run maybe more frequently, but in shorter stints. And this means that if we want to get our early warnings, we can no longer ignore startups, coast downs, and any transients in between. Achievements, well, the most important thing for us is catches. So our aim is contributing to enhancing reliability of our equipment. Let me tell you what we mean by catch. For a notification that we share with sites, for that to be classified as a catch, it has to meet two conditions. The first one is we're telling them something that was not noticed otherwise. For example, in an operator round or any other system. If we're telling them something new, and if this can have an economic value to our company, and the most likely situation is reducing the risk of unavailability, or maybe, and I will have a real case about that, reducing the likelihood of having larger damages to the equipment, that for us can be classified as a catch. Last year, we had close to, it was a bit over 25 catches. Half of them were related to critical trip sensor issues that were not noticed again, while the remaining half being related to either equipment or process situations. On top of that, after you implement a solution like that, it's like having, I keep saying that, it's like having tens, maybe hundreds, who knows how many, expert people constantly looking at your signals. You get the same result of that by using this tool that only highlights what's important for subject matter experts to focus on. So instead of having tens of people constantly looking at all your signals, you can detect automatically or in a semi-automatic way your relevant deviations by using this tool. As a positive side effect of this has helped us increase data awareness. So there's sort of constant push for reliable signals, reliable seamless data flow, reliable storage, and so forth. What are the things that we are supposed to do in the future? They may be new things or things that we have to finish and complete. I mentioned it shortly, transient monitoring. Well, again, we cannot longer ignore startups and coast downs. Over the past couple of years, we have developed ad hoc analytics outside the APM platform, focusing on specific failure modes we have an interest in. So we defined, instead of monitoring all the signals together as you do in a blueprint, we focused on a few failure modes, and we developed our own analytics for fast detection of things happening in transient situations. What we want to understand now is how we can incorporate these additional sources of information into APM, because at some point you will want to have all your relevant information, all your relevant insights in the same place. Well, the ideal thing would be having cycle watch-like models for all kind of equipment we have an interest in. That's top decide. If this is not possible in a reasonable way and relatively soon, we'll go another way, like, and this is what I mean by has health overview. At least we want to combine this information coming from other sources to generate alerts, additional alerts, or get an overall health score for any asset that we monitor in APM. We are exploring connectivity options that we have to get this information into APM, and then we will probably consider the health option. I'm not saying that we're going to do this in APM. Again, my top desire is having cycle watch-like models. Again, we started a discussion with product team about what's going to be available in the near future. But if the timetable does not match our needs, we may want to have sort of a general dashboard, a global overview, and APM health is a possibility for us that we want to explore. Last one, CBA. Some of you may be aware that there's a built-in tool inside APM that is called CBA, or cost-benefit analysis. We started using it beginning of 2023 to track all the benefits that originate from our work at the M&D. We developed a workflow that was agreed upon. What we still need to do is having the economics double-checked and eventually validated by management. This was one of our biggest goals when we started 5 years ago. We're not there yet, but at least we started 1 year ago, and that tool was really helpful for us to have a process, have a workflow. It combines the probability of something with an impact. We now at least have a workflow. We're getting close, and I think that in 1 year we'll be there. Now let me show you 3 real cases we had last year. The first one is about gas turbine, and specifically a valve in this gas turbine that is called inlet bleed valve. The case was about detecting a valve anomaly, and specifically this valve was lagging behind opening requests by the control system. I will show you the evidence in a while. This is something important, and we raised this notification to our site people pretty much immediately. They inspected the valve at first opportunity and found what we call valve sticking, which pretty much means high friction between moving parts inside the valve. They repaired some parts, maybe replaced. I don't have the full details on the repairs, but I do know that proper valve operation was restored in a matter of hours. And what is the value behind the story, in our opinion? To answer this question, you need to try to understand what was going to happen to a certain level of likelihood if this situation was ignored or if we didn't have this notification. It is likely, considering how things were evolving, that this valve was going to be inoperable at all by the control system, and you can still get lucky and start up your machine and operate that, but the likelihood of having a startup trip or even unstable steady state operation because of an unusual combustion mode resulting in higher emissions, the likelihood of all this rises. So this is the value, and we try to track this in the CBA. We made some assumptions about the economic behind that. I will not discuss again because that's not been validated by our management yet. What is the evidence supporting this? This came to us as a standard SmartSignal notification in our alert tab, but as a supporting evidence, I will show what we call event frame analysis. That is an alternative visualization you may have in APM reliability. You will see 8 different startup situations side by side. And for those of you who are not familiar with either SmartSignal or APM reliability, the blue line is the actual signal coming from your control system, while the green line is the expected behavior of that signal that is calculated by the SmartSignal algorithm. And by comparing the two of them, you can understand if your equipment is working properly or not, to make it simple. The first, you see this unfolded during startup. The second one is the actual valve position. And you will see that in 3 different situations, this one that is January 9th, this one, and this one, the actual valve operation was way different from the expected situation. So this one is another possible visualization you may have in APM. It's called the analysis tab. It has nothing to do with SmartSignal, but it's a thing you can use to better compare your historian data. This is an overlay trend, simple one. This is January 9th, one of the 3 situations I pointed out earlier. The blue line here means the opening request by the control system. The orange one is the actual valve position, and you can easily see that it was taking over 10 minutes, which is way too long for this valve to open on that day. The last one here, the last startup situation, was after the valve was repaired, and so the issue disappeared. It was not persistent, it was specifically manifest in cold startups. Still, it was getting more frequent and the magnitude was increasing. Second one is about a condensate pump anomaly, and specifically APM diagnostics detected a sharp rise in vibrations on a condensate pump motor. Again, we notified site immediately, and at first opportunity, they replaced the motor with another one they had in stock, and the motor was sent out for repairs. I do have the details this time about the failure. When the motor was inspected, they found that there were some iron bars in the motor, and they were loose. So if this was going to go on like that, it is very likely that it was going to lead to a short circuit in the motor, so a much larger damage to the equipment. In terms of availability, it has to be considered that this specific power plant has two fully redundant condensate pumps, so the likelihood of having complete high availability for the power plant is not that high, yet in our experience, not zero, because the backup pump, standby pump was supposed to kick in case the master one fails. What's for sure is that if you allow something like that to go on, you're likely to get a short circuit in your motor, and that's something you don't want. Again, the evidence, that's standard SmartSignal visualization or APM reliability. I kept confusing the words as they are pretty much the same thing in different places. So the light green box shows normal operation, and you see that the expected value and the real one were very close. So this is the difference between the two of them. It's called residual, and it's near zero. This is a vibration measurement in millimeter per second. I know you have different units, so it's like inch per second, but it's the same thing. That's the failure. The red box, you see this sharp rise here. And this is what happened after the motor was replaced with another one. As you can see, here we still get notifications by SmartSignal, but the reason is quite simple. It's because this model is no longer representative of our equipment. We need to retrain that because it's another motor, plain simple. We need to wait for some historical data to accumulate, and after we have enough historical data, in our opinion, we go on with retraining. Last one, step-up transformer for steam turbine. In October last year, thanks to reliability analytics in APM, we detected higher than usual temperatures in this transformer. When site people were notified about that, they found that two cooling fans had failed, thus not providing enough cooling for the transformer anymore. This was detected very early. The fans were replaced and normal cooling was restored again. What is the value? Well, I'm not a transformer expert, but I've had the chance to speaking to some of them over my career, and they are very concerned about overheating in a transformer. If you allow continuous operation in a transformer that is not properly cooled, you will eventually reduce the remaining equipment operating life. And this one, in my opinion, is really interesting to understand how SmartSignal can help you detect very early deviations that would otherwise be unnoticed. Again, the failure here is in the trend that is highlighted in the red box. And you can notice here that your blue line, although being some 8 or 10 Celsius above the expected value, is well within operable limits. If you move further here, the dark green box is after the fans were replaced. So this is normal operation again. And here you have actual values that are that are higher than those you had here when the equipment was not operating properly. So this means that unless you compare your equipment situation with an expected behavior, something like this will 100% go unnoticed. And if it goes on like that, so load must have been different here, because otherwise it's impossible. If you continue to operate your equipment like that, when it goes in more demanding operation like summertime, high load, this situation amplifies, and it has to be taken care of at a later time. So that's, in my opinion, a good example of what early detection means for us and how APM reliability can help us achieve this goal. Well, this is actually the second time I deliver a presentation like this. The first one was a couple of years ago at a regional event in Barcelona. The only thing I kept pretty much the same as this quote. And that is, in my opinion, what I want to point out here is that, well, there's still something that is really powerful, at least for steady state monitoring. But for you to achieve results, you have to take care of your models. Of course, when you implement them, but also afterwards. I mean, you need to continuously work to understand what the alerts are about and to constantly update your models.